Next up on stage is Dov Phillips from IDS, and he will give a presentation on Ultraprecision Aerosol Deposition applications in 3D printing and packaging. Let's welcome the speaker to stage.
All right. Hello, everyone. Thank you very much for attending this presentation today, and thank you for TechBlick for hosting this event that's been quite productive. I'm Dov Phillips with IDS, and yes, today I'll be presenting on precision aerosol printing in 3D spaces. To start with, provide a little bit of background on the company itself. So IDS was founded in 2013 by a pair of aerosol generation kind of pioneers who had their background in the initial DARPA development of the technology in the 1990s and early 2000s. The first system was shipped in 2017. That system was actually shipped to Rochester Institute of Technology. At that point, we were just providing a simple print head module that could be integrated onto an existing motion platform. Since that system was shipped initially, we've added significantly more capabilities, not only in the core technology of our systems, but in the full system sets that we sell. So we now have complete systems with motion, integrated optical systems, heated and vacuumed platens, and even growing list of capabilities. But in general, the mission is still relatively the same, and that's to create the next generation of aerosol printing technology with the aims to be reliable, friendly to use, and geared towards production applications. So this is all accumulated in the NanoJet aerosol print systems. These systems provide robust print performance with 8 hours or more printing stability. So that's generally the amount of time that our systems will print before any need for refilling the ink. Our systems are known for having very high quality line edge definition. So for us, that means a lack of overspray, which was very common in older aerosol printing technology. We're able to print reliably down to around 10 micron trace widths. By adjusting the parameters and print settings, this can be expanded all the way up to 200 or 300 microns in a single pass. We've effectively eliminated satellite deposition, so that would be the large particles that kind of spray in different areas and more common from physical shutter on earlier systems. And probably the most important, they're easy to operate and maintain. So for us, that means it should be quick to train, relatively easy to clean, and have relatively a small amount of actual downtime so that you can use these machines for production and not just as a paperweight in your lab. To give a little background on the kind of fundamentals behind aerosol printing technology, it's pretty straightforward. It starts with creating some type of polydispersed aerosol stream, and then sending that through the system, going through some kind of nozzle and onto the substrate. IDS, our innovations are kind of specific to our focusing technology, which is the use of a hydrodynamic and aerodynamic focusing of the sheathed aerosol stream. This sheathed aerosol stream is actually saturated in the solvent of the inks that we use, which prevents things like evaporation and allows for better surface wetting and ink deposition. We've also minimized the travel of the aerosol stream to the dispense point. Excuse me. This is important because the longer the stream into the actual nozzle, the more chance that particles can fall out of collimation, that there can be some kind of clogging that would occur, or that you may just have a distribution that's unfriendly to what you're looking for. If the larger particles go to the outside, that's how you can get some of these overspray and